and linked list is divided into two parts, that is and back is a pointer field that contains the address of the previous node. Queue is a linear data structure. It follows first in first out mechanism. The last node contains the memory address of the first node. Linked list is a linear data structure and it is a linear collection of. Link means it consists of the address of the another node. The last node contains the address of the first node is called as circular linked list. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed about queues. So, what do you mean by queue? Queue is a linear data structure. It follows first in first out mechanism. It follows FIFO mechanism. The element which is inserted first must be removed first. That is first in first out mechanism. Queue is a linear data structure. It follows FIFO mechanism and insertion takes place at one end called as rear end and deletion takes place at the other end called as front end. So, insertion takes place at the one end called as rear end and the deletion takes place at the other end called as front end. This procedure is called as NQ. And this procedure removing of element is called as the DQ mechanism. So, queue is a linear data structure. It follows first in first out mechanism. The element which is inserted first has to be removed first. That is called as queue. And also I have discussed the memory representation of queue. So, here we have one queue with 4 number of elements with location 0, 1, 2, 3. Here, how to represent the front and rear end? The front is 0th location and the rear is here 3rd location. So, this is called as front. Front is equal to 0, rear is equal to 3. Today, I am going to discuss about the new topic called linked list. So, what do you mean by linked list? Linked list is a linear collection of elements called as nodes. In linked list, elements are not stored at contiguous memory location, but all the elements are arranged in any location. It can stored at any locations, but there will be a link between every node in the list. So, linked list is a linear data structure and is a collection of elements called as nodes. And it is divided into two parts, that is data or information and link. So, list can be divided into two parts. The first part, this is the first part, contains the information of the element, information or data. The first part contains the information of the element and the second part contains the memory address of the next node. The second part is link. It contains the memory address of the next node in the list, also called as link part. So, the first part contains the information of the element and the second part contains the memory address of the next element called as link. So, in linear data structure, elements are arranged in any location, but there will be a link between every element in the list. So, here we have two parts in list, that is data or information, and one part is link of the next node. Example, here we have 3 nodes. The start or head. The start is also called as head. The start or head is connected to the first node and the first node is connected to the next node and the next node is connected to the next node. Here there will be a link between every list. So here we have two parts of this field, that is information or data, that is the information of the element, and link between the other element. So this is information of the element and link of the next node. So there will be a link between each and every node. So here we have three nodes, node 1, node 2 and node 3. So first data is element 30, and here the link means is a pointer. Link means it consists of the address of the another node. This link part is consists of the address of this second node, that is the element 20. It shows the address of the next element, and this second node link is consists of the address of the third node called 10. And only we have three nodes. The last link is called as null. There is no other element. So last link is called as null. Here we have only three nodes. Node 1 is connected to node 2 and node 2 is connected to node 3. The last link part is called as null because there is no extra element to connect it to this link. So this is called as linked list. Linked list is a collection of data elements called as nodes. There will be a link between each and every node, and linked list is divided into two parts, that is data and link part. Data part, information part and link part. And the left part of the node represents information of the node, that is data. The left part represents the information of the node and the right part represents the link part, that is pointer field that contains the address of the next node. This link part contains the address of the next node. And a pointer is start or head gives the location of the first node. It gives the location of this first node. This is node 1 and this is node 2. This is data and this is link. The pointer start or head gives the location of the first node and the link field of the last node contains null. The link field of this last node contains null because there is no extra element for connecting the pointer. So this is called as linked list. Linked list consists of two parts. Every part is connected to the next node. One part is data, another part is link part. And we have some examples in linked list. That is singly linked list SLL and doubly linked list DLL and circular linked list CLL. Types of linked list is singly linked list, doubly linked list and circular linked list. So first one is singly linked list. Singly linked list means single list. Singly linked list. So singly linked list contains two fields in each node, an information field and the link field. Already I have explained. Linked list consists of two parts, that is information part and link part. The information field contains the data of the node. This is the data of this node, first node, and we have three nodes here. The data information consists of the data of this first node, the data of this second node, the data of this third node. And the link field contains the memory address of the next node. This link field consists of the memory address of the next node. And there is only one link field. There is only one link field in each node, that is called as singly linked list. Only there are one link for each node, that is called as singly linked list. Singly linked list consists of only one link in each node, that is called as singly linked list. Here we have three nodes, that is node 1, node 2 and node 3. And we have two parts, that is information and link. In singly linked list we have only one link in each node, that is called as singly linked list. Very simple concept. And next we have doubly linked list, DLL. In doubly linked list, each node is points both to the next node. Each node is points both to the next node and also to the previous node. Each and every node is points to the next node and previous node. In singly linked list, we have only two parts, that is data and link part. But in doubly linked list, we have three parts. So first part is forward, FORW. It is a pointer field that contains the address of the next node. Forward means it contains the address of the next node. This is forward part. It contains the address of the next node, and back, it is a pointer field that contains the address of the previous, called back. Here in doubly linked list we have three parts, that is forward, back and info. Info means information. It contains the actual data. So here we have forward, back and this is info. And info, it contains the actual data. This is info. In doubly linked list we have three parts, that is back, info and forward. Here this forward represents the address of the previous node. This forward represents the address of the previous node, and this is called as back, and this is the actual information, and this is forward. This forward points the address of the next node, and this backward finds the address of the previous node, and this is actual information, and this is forward. It points the address of the next node. So forward is a pointer field that contains the address of the next node, and back is a pointer field that contains the address of the previous node, and info contains the actual data. Back contains full. In the first node, here we have a null, that is back. Back contains a null value, indicated that it is the first node in the list. So null means it is a first node in the list, and this is the second node, and this is the third node, and this is the last node. So first node indicates the null, and the node in which forward contains null indicates the node is the, so here back indicates the null, that means it indicates the first node, and forward represents the last node. So this is called as doubly linked list. I will give one example for doubly linked list. So start, and so first node indicates three parts, that is null, back, this is information, that is we have 45, and this forward indicates the address of the next node, this is back, and also it represents the address of the previous node, and this is info, we have 50, and it indicates, forward indicates the address of the next node. Here it also indicates the address of the previous node, and info is 60, and this is forward, it indicates the last node. So this is the example for doubly linked list. And next we have circular linked list. CLL stands for circular linked list. In circular linked list, the last node contains the memory address of the first node. This last node contains the memory address of the first node. So this is the first node, second node and third node and fourth node. We have four nodes. The last node indicates the address of the first node. This is node 1, 2, 3 and 4. The last node indicates the address of the first node. And in a circular linked list, every node is accessible from a given node. This node contains two parts, data and link part. Each node accessible from given node. And the last node contains the address of the first node. This is circular linked list. The last node contains the address of the first node is called as circular linked list. So we have studied singly linked list, doubly linked list and circular linked list. Very important question for 3 marks. And next we have memory representation of queues using linked list. Already I have discussed queues in my previous session. So today I will discuss this memory representation of queues using linked list. In queues, the element which are inserting first has to be removed first. That is first in first out mechanism. Queues follows first in first out mechanism. How to represent queues using linked list? So in queue, an item should be inserted from rear end and an item should be removed from the front end. Already I have discussed. In Q, the item should be inserted from rear end and the item should be removed from the front end. How to represent a queue using linked list? Here we have rear and front. So we have three nodes, node 1, node 2 and node 3. The first node is connected to the head, that is starting point. Head is connected to the first node and we have two parts, data part and link part. This link part accesses the address of the next node. Here the first data is 50 and link part accesses the address of the second node and this link part accesses the address of the third node. So this is the representation of queues, and here we have front is node 1 and rear is node 3. Null means there is no link for connecting the next element. And here we have head is connected to the first node, node 1, node 2 and node 3, node 4. Here we have 4 nodes. So for front is node 1 and rear is node 4. You can observe these two nodes. In first example, I have only 3 nodes. In the next example, I have added one more node called node 4. I have inserted 75, that is node 4, and you can observe this third example. Here I have deleted one element called 50. Here I have deleted the first node and we have 25, 20 and 75. This is node 1, node 2 and node 3. So front is N1 and rear is N3. So this is the memory representation of a queue using linked list. How to insert an element and how to delete an element using linked list. Very simple concept. And next we have the operations on linked list. Which are the operations can be performed in linked list? Creating a linked list. So we can create a linked list and traversing a linked list. Traversing means already I have discussed in stacks. Already I have discussed. Traversing means visit each location of the element exactly once. And inserting an item into a linked list, I will explain later. And inserting an item into a linked list, how to insert an item using linked list and how to use, and we have deleting an item from the linked list and searching an item in the linked list, searching an item from the linked list and merging two or more linked list. So these are the operations performed in linked list. So first operation is creating a linked list. While creating a linked list, we have to use structure declaration. Already I have studied in first PUC. So we have to use structure declaration for creating a linked list. So we have to use structure declaration, struct node and open flower bracket and int info. Int info means you can use any other type of values like integer, float, character, etc. Int info and struct node of link. Struct node means which node you are using. To hold the address, I am going to take a pointer variable called link. To hold the address of the node, we are going to use a pointer variable called link and close the flower bracket. We have to mention the nodes, node 1 and node 2. Here I have taken the information. Info means is the information field and link is the link field. Information field and link means is the link field. And here link field contains the pointer variable. So using this operation we can create a linked list. We have to use structure declaration. New means it's allocating a memory space, that is the operator is new of. It allocates a memory space for array, and delete deallocates a memory space for array. The operator is delete of. So what is the syntax for new operator? Pointer is equal to new type and number of elements. Example, int star temp temporary variable temp is equal to new int of 5. So this is a syntax for new operator. Pointer is equal to new type and number of elements. And this is the example for allocating a memory space for array. And this is a syntax for delete operator, delete pointer. And so next operation is traversing. Traversing a linked list. Very important question. Traversing a linked list. Traversing is the process of accessing each element of the linked list exactly once. That means it visits each location of the element exactly once. So next we'll see the algorithm for traversing operation. Traverse start P. Start contains the address of the first node. Another pointer P is temporary, used to visit all the location of the linked list. So P is visit all the location of the linked list, and P is equal to start. P is equal to start means it started visiting each element of the linked list exactly once. So P is equal to null means we have to check the condition whether there is an element for visiting each and every node. Process data of P. Example, start. It connects to the first node called data is 25, and link. It accesses the address of the next node. This is node 1 and this is 35. This link part connects to the address of the next node. So here we have three nodes, node 1, node 2 and node 3. This is null. There is no extra node for connecting. Here P is equal to start. We have to check the condition. P is equal to null. Whether there is an element for accessing. Here I am using while loop, and process data of P means P visits each and every node exactly once. So P is equal to link of P. So first it will visit the first node and again it will visit the second node and last node. So traversing means process of accessing each element of the linked list exactly once. So first you need to check the condition P is equal to start. From the beginning you need to access the elements exactly once, while P is equal to null. Check the condition P is equal to null and process data of P. So P visits every node exactly once. So this is your algorithm for traversing linked list. So today we learnt linked list definition, examples and types of linked list. Mainly there are three types of linked list: singly linked list, doubly linked list and circular linked list. And also I have discussed memory representation of queues using a linked list and the operations of linked list, and also I have discussed the traversing operation. In my next session, I will come with the next operation called insertion and deletion using linked list. Thank you.